Okay, hello. So today we are going to go over the first part of 5.3, probabilities using counting methods. So by counting methods, we mean three different things. Number one, the fundamental counting principle. Number two, permutations. And number three, combinations. So they are all, of course, counting methods we have studied before. So today what we're going to do is start to apply them towards probability. So when you think about it, probability is about the counting of number of favorable outcomes and the total number of outcomes. And the fundamental counting principle, permutations and combinations are ways to help us count. So let's look at some examples together. It says example 1, two cards are drawn without replacement from a deck of 52 cards. We're going to calculate the probability that both cards drawn are aces. So there are a couple of different ways to look at this question. Number one, we are going to draw one card at a time and see what happens. So we're looking at the probability of two aces. Now there are, as you know, four aces in a deck of cards out of a total of 52 cards. So that's our first number, 4 out of 52. Now once the first card is removed, we will only have 51 cards left, of which only 3 of them will be aces. So from there, what we can do is simply multiply the numbers together. 4 times 3, of course, is going to be 12. And then 52 times 51 would be 2,652. Now, if you divide those to give a um, decimal and then a percentage, it'll work out to be it's around 0.45%. So not particularly likely, but you can expect that drawing two cards and getting two aces. Now, the other way of doing this question is to think about it in terms of combinations. So you have four aces in the deck of cards, and you want to choose two of them. Those are what we call the favorable outcomes. Those are the ones we want. Now, the total number of outcomes would just be we have 52 cards and we just draw any two of them, right? So you can see that the 4 choose 2 are the aces and the 52 choose 2 is the any card, any two cards. So this is 4 aces, you choose 2, 52 cards, and again you choose 2 to represent the favorable outcomes and then the total number of outcomes. Now if you use a calculator to do this, you'll get 4 choose 2 is equal to 6, and then 52 choose 2 is 1,326. So you notice that the fractions are the same. It's just that both the 12 and the 2652 were divided by 2 here. So of course, when you convert it to a uh, decimal then to a percent, you will get the exact same value. So really, you can do this question in either way. Whichever one way you think is more intuitive, that's the one you should go with. Okay, next question. So a bag of marbles contains 5 red, 3 green, and 6 blue marbles. A child is going to grab 3 of them. We want exactly 2 blue. So we don't want 3 blue, we want 2 blue. A very important distinction there. So let's look at how we can do this question. Use blue for the blue question. 2 blue. Now there are 6 blue marbles and we need to choose 2 of them. So we can do that. And then we have one more marble that we must choose, but that one cannot be blue. So we actually have 5 red ones and 3 green ones. So that's 8 not blue marbles we can choose from. So that will be 8, choose 1. So that will complete our 3 marbles that the child will grab from the bag. 2 of them are blue and 1 of them that is not blue. So this is 2 blue and then 1 not blue. And of course, as usual, we're going to divide by the total number of outcomes in the sample space. So there are how many marbles? Let's see, 5 plus 3 plus 6. So that's 14 marbles. And we can choose any 3. So that will just be 14, choose 3. Okay, so if you use a calculator for this, 6 choose 2 is 15. 8 choose 1 is of course just 8. And we will divide it by 14 choose 3, which is 364. So once again, you can just simply divide those, um, and you'll get just under a third. So this would be 32.97%. Okay. Next up, very similar question. 2 seeds are chosen from a packet containing 10 of them. 3 that will produce red flowers, 4 that will produce white flowers, and 3 that will produce blue flowers. So if we want 2 red flowers from 2 seeds, and this is a little bit easier. So probability of 2 red, there are 3 red seeds, or 3 seeds that will produce red flowers. We're going to choose 2 of them, and that's it. Those are all the favorable outcomes. And we divide it by, let's see, 10 seeds in total, they say. So 10 choose 2. So 3 choose 2 is 3. 10 choose 2 is 45. So this would be, you can simplify it to 1 out of 15 as a simplified fraction, or you can convert this into a decimal or percent, and it works out to be 6.6%, sorry, 6.67% approximately. Okay, so that's that one. Now, a lot of the questions that you see involve cards. So let's look at one of them together right now. We're going to play with a simpler deck of cards. We will only have 9s, 10s, jack, queens, and kings, and aces. So that's 6 different ranks for 24 cards in total. So you can see here that each player, so there are 24 cards, important. And then you only have ace, 9, 10, jack, queen, and king. And of course, in the 4 suits, and each player is dealt 5 cards. So those are the important bits of information for that question. So it's the first question asked to determine the probability of a dealt hand with ace, king, queen, and jack of the same suit. So probability of that would be, let's see, I'm just going to write it out. Now, in a deck of cards, there are 4 suits. So I'm going to choose one of them. So 4, choose 1. This is again for the suit. Now, in that suit, there is 1 ace, 1 king, 1 queen, and 1 jack. So that would be 1, choose 1, which of course is 1, but we have to do that 4 times. So that doesn't affect our product because we're just multiplying by ones, ones, 1, 1. Now, the last card, we have 5 card hand, so the last card still needs to be dealt. There are 20 cards remaining. I'm going to choose one of those. Any one of the remaining 20 cards. And then we will divide by the total number of hands that are possible. So that will be any of the 24 cards, and then we will choose 5 of them. So 4 choose 1 is 4, of course, and then we have ones in the middle part here. And then 20 choose 1, of course, is 20. So we have 4 times 20 divided by 24 choose 5, which now if you use a calculator to figure this out, this would be 42,504. And of course, you can write your answer as a percent. So that would be 0.188%. So the next part is about cards of same color. So let's look at how this one works out. So we have the probability, same color. Again, you can just write a short description as to what the question is. In this case, there are 2 colors, so 2 choose 1, red or black. Now within each color, there are 12 cards, and they all have to be the same color, so you can choose all 5. Then you can divide by, divided by the um, total number of possible hands, so that would be 24 choose 5. So you have the first part is going to be 2 choose 1, which is 2. 12 choose 5, which is 792. And then we already got from the previous section 42,504. So again, you can multiply it and divide. And the answer in this case, that works out to be 3.73%. It's about. Yeah, so again, the important thing to note here is this is the 2 colors. This is 12 cards of the same color. All right, so last part, we have 4 of a kind. So let's at how that's calculated, the probability. So we have 4 of a kind. So there are 6 different ranks in this version of the card game. So we're going to choose one of the 6 ranks. It could be 9, 10s, jacks, queens, and kings and aces. Once we know our rank, we have to choose all 4 of those cards. So that's 4 choose 4. And it's still a 5-card hand, so the last card could just be any of the 20 remaining cards. All right. And then, of course, you will divide by the same number, 24 choose 5. So there's a nice pattern to these questions because you're always dividing by the same denominator. So again, if I were to go ahead and label this, this would be 6 ranks, all 4 cards. And then this is any remaining card. All right, so from there we have 6 times 4 choose 4, which is 1, 20 choose 1, which is 20, and then divided by a very familiar number, 42,504. So that will be 120 over 42,504. And if you divide using a calculator, you'll get 0.282%. Rounded, of course. And that's it. So that's it for today. We will continue with an example that has permutations tomorrow. But that is it for today. So thank you for listening.